Hi everyone, welcome to today's coding session. We'll be tackling the task scheduler problem in Python by exploring the three increasingly efficient approaches. First, we're going to do the brute force simulation, which is a manual scheduled task with coding interval, simple but inefficient for large inputs. Then we're going to do the greedy with counter. It uses a task frequency and a formula to compute the minimum interval, avoiding step-by-step simulation. And we're going to use the greedy with array optimization, which replaces the hash map with a fixed size array for faster performance and lower memory. It's perfect for a task like the one we're about to be given. As we code, I'll explain the code for the different approaches, walk through an example code execution, and show the runtime comparison. Here I'm just showing you a preview of what we're going to be dealing with and how we're counting it. Here is another way of looking at the same problem, and here's just an emphasis of that the greedy approach is not necessarily going to give you the best answer. As you can see, this would have been the best answer, but it went this route instead. So before we jump into the code, let's first understand what the task schedule problem is asking. So here's the setup. You are given a list of tasks, each represented by a capital letter from A to Z, an integer n, which is a cooling interval. Meaning once you run a task, you must wait at least n interval before running the same task again. So each time unit, the CPU can either run a task or remain idle if no eligible tasks are available. So the goal is to determine the minimum number of intervals the CPU needs to complete all the tasks while respecting the cooling interval between identical tasks. And here's an example walkthrough. So example 1, we want two cooling interval between the repetition of the same letter. So here, what we have is 3 of the same letter and 3 of this letter as well. And as you can see here in the example, we want 2 cooling interval, but the problem here is that there's 3 letters. So because of that, we need 3 spaces, including the A, which would be A, and then we can start A. So at least two idle spaces is what this is asking here. But because of the repetition, we need at least 3, counting the letter that we use, spaces between we can repeat it again. And that's why in this case, we only have 1 idle space, because there is this letter repeats 3 times, and since there's 2 interval, you won't see the effect of the spacing, as is space 1, space 2. And here, to bring it home, same thing, we got 3 A's and 3 B's, and as you can see here, the output was 8, but we could have simply had, if we had no idle time, we would have simply had 6 tasks, right? Because we got 3 A's and 3 B's. Now here, the same thing, we would have had 6, but instead it's 10. And the reason for that is because we need to have 3 idle time before the letter repeats. This right here means the gaps between the letter A. So now, as you can see, to count the gap, we got 1, 2, 3, gap, and then the A repeats again. And that's the reason we have 2 interval, because we only have 2 letters, A and B. And we can't put B also, because B also has a gap of 3, because it repeats 3 times, and n equals 3, so you must have 3 out of time. And that's why you got B, then 1, 2, 3, and then B repeats again. And the reason you get A and B, I'll explain more in detail, but it just comes down to the fact that there's 3 A's and 3 B, and the only way this will work out with the gap required is that we have an A and a B that remains at the end. Now here, we have the same requirement, but here it's saying, now we don't have a repeating A more than twice, and 2 B's, and then we have C and D. So in this case, we only need 1 space between the repetition of A. The difference between example 1 and 3 is that here, you're able to process B before you have to do A again. And not only that, but you can go straight to C and then D, and now you can repeat A, just because there's so many letters we can go through. In these scenarios, we didn't have that ability. We only had 2 letters, and therefore we had to have an idle time in both cases. So now that we understand the problem, let's look at the constraint we need to consider. So the number of tasks range from 1 to 10,000, so we need an efficient solution, ideally big O of n. Each task is an uppercase letter from A to Z, meaning we'll have at most 26 unique tasks. The cooling interval n is between 0 and 100. And n equals 0 means there is no cooldown at all. So let's keep this in mind as we move forward with our implementation. So just a brief overview of our brute force approach. In theory, we could simulate the scheduling process, track task cooldown, choose the next available task at each time step, and insert idle interval when needed. But here's the problem, it gets messy fast, and the performance drops dramatically with large inputs. So for competitor coding or real-world application, we need something faster. And this is why I'll be showing you in this code the optimized greedy solution. Here where things get interesting. We can solve this problem efficiently using a greedy math-based approach. So the key idea for this is we'll count the frequency of each task, focus on the most frequent task, and build a frame around those tasks with enough space, idle slots, to separate them based on the cooling interval n. So let's implement the code. So the first thing we're going to do is we're going to import a Python built-in counter. And the reason for that is because we want to use this counter to see how often a task repeats. And here we have task, which is the input we were given here that shows all the tasks we have to complete. And we're using the Python imported function that counts how often the task repeats, and then we store that in the task counts. So after we found all the counts for all the letters, all the tasks that we came across, now we're trying to find the max value, and we're going to store it into max frequency so that we know what's the max frequency for a task. How often does it appear and which one is the max. So this part of the code, we're doing a for loop where we're going through the task count items, which will be here, which we created, the task. We get all the items, we're seeing how often it shows up. And here, as we can see, is saying does frequency equals max frequency, because what we're looking for here is to see how often does the max frequency occur. Example 1 and 2 and 3, we saw that the frequency of A appeared 3 times and the frequency of B appeared 3 times. So the max frequency 3 appeared twice. And here, this is the big deal here, because originally, like task is showing how many tasks we have to complete, and interval is taking into account how often the max frequency occurs and the gap that we need to have between each letter, as we saw in each example 1, 2, and 3. And then max count will be the count that repeated, as we measure here, how often did it repeat. And as we saw, there was 3 A's and 3 B's, so the number 3 appeared twice. So here is where we're going to have the number 2 to represent the A's and B's that showed up. And here, in detail, we are going to get the length of the task to see how many tasks we have, and interval, which is what we calculated, including idle time, which is considering how often the number shows up, maximum, and the gap that has to be between the letters. Whichever one of the two is greater is the one that we're going to return, because at the end of the day, what we want to track is, do we need gaps or not? If we don't need gap, length of task and interval will be the same. If we need a gap, interval will be greater, and that's what we're going to use in order to create our arrangement of our task. So let's see how the code runs. Okay, as you can see here, pass all 3 test cases, and let's see how it compares to others. And as you can see here, it is very efficient, 38 milliseconds, it beats 89% of other code, and it's also very memory efficient as it beats 85% of other code. And one thing to mention here is that this result changes depending on what time of day you run this code. or any code. So now let's look at an example. So here we're given a task. It has 3 A's and 3 B's. These are the tasks we need to complete, and we need to have a gap of 2 between each letter. Each repeating letter, like A. There needs to be a gap of 2. And now here, task counter, as mentioned before, this one counts how often or the frequency of each letter. And we already know that A shows up 3 times and B shows up 3 times, and that's how we ended up getting that as a dictionary. A being the key, 3 being the value. And now here we're getting the maximum values, which is 3. And then here, as mentioned before, we're trying to find how often does max frequency show up. As we can see, it shows up twice. So you can see there's 3 A's and 3 B's, so that's 3 shows up twice. And you can also see it here, 3 shows up twice. Now here, this is key for this entire code, because this right here is what's going to determine whether we're going to include idle time or not, whether the CPU will run a task or remain idle. And here I give you a breakdown of what's going on. Here's the number, and here's also the calculation behind it. So max frequency, as we know, is 3. And max frequency is again used to show the gaps between repeated tasks. And then here, n+1, each gap includes the task plus its cooldown. So in this case, we're actually accounting for the task itself plus the gap that we want. And then when we do the multiplication, what we're trying to do is this: we're trying to figure out how many rows are we going to need. That's the reason we multiply 2 times 3 after we do the addition of this and the addition of that. We want to figure out how many rows we're going to need, and that's the reason we're doing a multiplication. And as mentioned in the example, the reason why we do a max count is because at the end we're going to have remaining the A and the B, because they're telling you how often the number 3 shows up in this case. And since there's 3 of them, 3 letters, 3 A's, 3 B's, then we're going to have left over an A and a B. And that's the whole goal of max count, to see what's going to be left over so we can put it at the end. And as you can see here, interval is 8 and the length of task is 6. So we know we're going to need idle time based on the fact that interval, which is accounting for idle time, shows there's 8. And it is the max number between 6 and 8. And this is a result of how we're going to display it, as we saw it in example 2. Well, actually it's example 1. And again, that's just to say, A, there's 2 gaps as requested, which would be gap 1, gap 2. Since there is only A and B, we have to insert idle, meaning the CPU doesn't do anything during that time period. And then we go back to A, and again, same thing for B. We got idle time 1, idle time 2, and then we put B, because we always need that 2 gap, and that's just based on the fact that we were given the gap of 2 here. I hope this walkthrough helped you understand how to efficiently determine the minimum number of CPU intervals needed to complete all tasks while respecting the cooling interval. If you found this helpful, don't forget to like, subscribe, and stay tuned for more in-depth coding tutorial and algorithm breakdown. Now let's explore a slightly faster variant of our current solution, one that uses a fixed size array instead of a hash map. This small change will lead to better runtime performance depending on how LeetCode behaves. So let's dive into it. So previously we used the Python counter from the collection module to count task frequency. While that's simple and readable, it does come with some overhead. Since we know tasks are always capital letters from A to Z, we can just replace the counter with a fixed array of 26 elements. This gives us faster access time and uses less memory, especially useful when dealing with large input sizes. So let's implement the code. So here, since we're using an array, we're just initializing frequency to 26 to basically the value of 0. because there are 26 letters, and currently we are not accounting for any of them right now. And here the whole goal of this for loop is to go through each task from the input value here. And then by doing so, now we're going to identify, okay, so the ordinal value of task, depending on what letter, is going to change. But what's going to be consistent is that we're always subtracting the number 65 from whatever that task is. When we do that, what we're finding is the index that we built here. And by doing so, now we're going to be able to increment how often does that letter show up. That's the whole goal of this function, to figure out how often the letter shows up and increment it to reflect how often it did show up. And as the previous example show, we are just interested in finding out the maximum frequency. So after you find out the max frequency, again, what we want to find out is how many tasks have the same max frequency. And this will play a key role when we arrange our task. And the difference here is we're using frequency count, and this does the same exact thing. Same thing here. Before we were using an imported Python code or function, but instead we're doing it here. And you'll see later why. And as you can see here, it's the same as what we did before for the previous code. The only distinction is here we did not save this part to a value called interval. We just simply decided to just do the calculation. And that we'll see how it plays a difference when it comes to runtime. But it does the exact same thing. The end goal is to find out, do we need to add idle time or not? If we do, this is going to be returned. If we don't, we're just going to return this. They'll both be the same anyways. So now let's see how the code runs. Okay, as you can see, it passed all three cases. And as you can see, this one, when it comes to runtime, is a little bit more efficient. It beats 92%, but it's not as efficient when it comes to memory. But again, I'll show you in regards to our runtime and time complexity, more detail for that to come. But before we do that, let's just go into our examples. So again, task and our, whether we want the CPU to, the gap that we want between the task. And we're initializing frequency. Again, there's 26, so that array is going to include 26. And here we're showing you the ordinal value. The letter A starts at 65 ordinal value, all the way up to 90 with the letter Z. And then the index, which will be for frequency, along with the letters, and the current value of frequency, which is 0. So now just giving you a walkthrough of the first letter we're going to get. Task is going to equal to A. And then this is what is happening right now. So we know that A is 65, and we're subtracting A minus A. So 65 minus 65, which will give us 0. And once we find that index, now we're going to increment that index so that we say, okay, we found the letter A once. So now you see that the value, the frequency, is now increased to 1. And this process will continue all the way till we build this. It's the exact same process that we showed in the previous example. A shows up 3 times, so we increment it 3 times, and B shows up 3 times, so we all increment it 3 times as well. And this is again showing you the subtraction that's taking place. Always 65, and 65 for A, 66 for B. And this is showing you the index where we started, and the letter as well, or the task that we were accomplishing. So now we're just finding which one is the max value or the max task. And as we can see, 3 was the max, and we initialized it to max frequency. Now we want to know how often 3 shows up. We know it shows up twice because we have 3 A's and 3 B's. So there's 2, the max count shows up twice. And then finally, we're just doing the calculation as shown before. This is the whole process in one, as explained in the previous problem. Max frequency is tracking the gaps between the task repetition, not after the last one. The n plus 1 is each group includes the one task plus n cooldown, like a row of slots, which is what you see here. And then we have the multiplication, and the multiplication again is just showing you the two rows, because there are 2, which would be 3 minus 1 will give us 2, and there are 3, meaning we're accounting for the gap plus the letter itself. As we can see, the letter itself and the gap, and that's where we end up doing this. So that'll give us, we need 6, a total of 6 spaces with 2 gaps. And then once this is complete, we also know that we're going to need A and B, which is the reason why we got max count. A shows up 3 times, B shows up 3 times. We already used them up twice. A and B would have been used up here. So now that leaves A and B at the end to be used up, which is what max count is counting, since that's the max frequency, twice. And then this is just showing you how we actually ended up displaying that. So let's quickly break down the efficiency of our solution. So the time complexity of both, even though you see a different value in LeetCode, because this right here is giving you worst case scenario, is big O of n. So we'll iterate through all tasks once to count frequency. Finding the max frequency is big O of 1, and since there are only 26 letters. And the space complexity is big O of 1, since we're using a fixed array or a counter of 26 elements, so space remains constant regardless of input size. So overall, our solution is both fast and memory efficient, and is perfect for handling large inputs. So I hope you enjoyed watching this tutorial. If you like the content, stay tuned for a future video. Otherwise, happy coding. See you next time.